What are these zany tessellations anyways? Well, a tessellation is a repeating pattern of polygons that cover a plane. The goal is to have a repeating pattern without gaps. Think of a tiled floor that never ends. When creating a tessellation, you may use one or more geometric shapes. These can be made by deforming a triangle, rectangle, or hexagon. Tessellations may also feature people, animals, fruit, whiteout bottles. Your imagination is the limit when creating these figures. What is the point of tessellating? Well, other than just having fun, you will learn to arrange several shapes so that they completely cover a surface. Pioneering the design, M.C. Escher wanted to show the beauty of math from an artistic perspective. A regular polygon has 3, 4, 5 or more sides and angles. These are all equal. A regular tessellation is made up of regular polygons. A little hint here, regular means that the sides and angles of the polygon are equivalent, or that the polygon is both equiangular and equilateral. Congruent means that the polygons you place together are all the same shape and size. There are only 3 regular polygons that will tessellate in the Euclidean plane. If you'll remember, the Euclidean plane looks a little something like this. You have your origin in the middle or at 0, 0, your y-axis, and your x-axis. All right, would you like to guess what those 3 polygons that will tessellate in this plane include? Well, if you guessed triangle, square, and hexagon, then you guessed correctly. So here's a few examples of what those tessellations may look like. So here's your triangle, and just pretend that those are perfectly even and lines are drawn just perfectly straight. Okay. So there's triangles. Here's a tessellation of squares. And then here is a tessellation of hexagons. All right, and then I draw a couple down here at the bottom, and you get the idea. All right, when you look at these 3 examples, you can see that the squares, they all line up with each other, no matter which square you look at. They're all in order. The triangles and hexagons are not. If you look at 6 triangles at a time, they form a hexagon. So let's look at 6 triangles so you can see what I'm talking about. So there's 1, 2, 3, 4, 5, and 6. And just to number those, I have 1, 2, 3, 4, 5, 6. So 6 triangles make up 1 hexagon. So the tiling of triangles and the tiling of hexagons are similar, and they cannot be formed by directly lining up shapes under each other. So in this case, we have to use a slide or a glide. You can work out the interior angles, or the measures of each of these angles, and that makes, let's see, a triangle would be 60 degrees at each angle. A square would be 90 degrees at each angle. And then a hexagon, if that actually turned out correct, would be 120 degrees for each angle. Okay? Since the regular polygons in a tessellation must fill the plane at each vertex, the interior angle must be an exact divisor of 360 degrees. This works for the triangle, square, and hexagon, and you can show working tessellations for these figures, but for all the others, well, the interior angles are not exact divisors of 360 degrees, and therefore those figures cannot tile the plane. Okay, so what's neat about this, and now we'll get into our tessellations. And these are examples of tessellations that you can draw. So a triangle, what can you do with a triangle? Well, you can create a bird from a triangle. Make him right through there. So if you deform a triangle, you can create a bird. Same thing here. You can look and make out a triangle there. And perfect and easy to do would be a Christmas tree. So you've got a triangle there, and they've just taken the sides in a little bit to deform that triangle. And then we have circles. Well, what can you do with a circle? Well, let's make an octopus. So here you've got your circle, and they have drawn tentacles, and they have deformed that circle to make several octopi. And then we have a circle here, and they have taken that circle and created waves. What about a square? What could you do with a square? Well, you can start up here. There's your solid square, and then you can see each line gets closer and closer until they have created birds again. And you can even make out the little faces that they've put on each bird. You can also deform a square until you make a puzzle piece. And here you can deform squares until you make a rabbit. So you can kind of make him out right there. And there's his little face and his ears. Now this one looks a little blurry, but they have actually made fish out of these squares. And he's a happy little guy floating down the stream. All right, well, those are just some examples of the tessellations that you can make. And one of my favorites, and I'm going to try this. Here is an apple for your teacher. All right, and I'm going to draw little heads. So he's got a little worm coming out of him. Actually, I guess they all need a spot for a head, so let me draw these. Okay. All right, and this little guy, they're all buddies, and they're just happy to be sitting in a geometry class and learning about tessellations. So the sky's the limit when you create these. Whatever you can imagine, you can somehow deform a triangle, a square, or a hexagon and create whatever figure you would like.